Hi everyone, I hope you are doing good. In this video lecture itself, I am going to explain about the single point cutting tool. Before starting my lecture, I would like to say what is single point cutting tool and what is the use of cutting tool. Cutting tool is used to remove the excess material from a raw material. Otherwise, machining the raw material in order to produce the one useful product. So that is the common definition about the cutting tool. And next, what is single point cutting tool? As name itself clearly defines the answer. If a cutting tool having only one cutting edge, it is called single point cutting tool. Yes, as its name indicates, a tool that has a single point for a cutting purpose is called single point cutting tool. It is generally used in the lathe machine, shaper machine, and etc. It is used to remove the materials from the workpiece. So I'm repeating. If the cutting tool having only one cutting edge, it is called single point cutting tool. Similarly, if a cutting tool consisting more than one cutting edge, it is called multi-point cutting tool. And why single point cutting tool? So what is the necessity of single point cutting tool? A single point cutting tool can be used for increasing the size of holes or boring. Turning and boring are performed on lathe and boring mills. Design and fabrication very easy for this tool. And this tool can be made at very cheaper rate as compared to the other cutting tools. So these are the major necessity of a single point cutting tool. And next, types of cutting tool. And generally, cutting tool classified into two major categories. The first one, single point cutting tool, and second one, multi-point cutting tool. So, as we discussed in the earlier stage, if the cutting tool consisting only one cutting edge, it is called single point cutting tool. And similarly, if cutting tool consisting more than one cutting edge, it is called multi-point cutting tool. Single point cutting tool. One cutting point or tip is available. Example, lathe machine, planing machine tool. And similarly, multi-point cutting tool. More than one cutting point or tip is available. Example, link cutter, grinding wheel, and drill tool. So these are the very familiar example of multi-point cutting tool. And types of single point cutting tool. The first one, solid type of single point cutting tool, tipped type single point cutting tool, indexable insert type single point cutting tool. So these are the three different categories of single point cutting tool. And next, materials. So cutting tool materials. Single point cutting tool can be made from several materials or the first one, high carbon steel, also called as HCS, and high speed steel HSS, ceramics, cements, diamonds, cemented carbide CBN, cubic boron nitride. So I'm having one question. So why single point cutting tool made from these seven different materials? Because so we know each and every cutting tool used to remove the excess material from a raw material. So obviously that cutting tool consisting the more hardness and mechanical properties than the raw material. That's why usually the cutting tool made up of these seven different types of material. And single point cutting tool geometry. So that diagram clearly shows the systematic layout of single point cutting tool and what are the geometrical parameters influenced in single point cutting tool. The first is the face, cutting edge, back rectangle, nose radius, flank, side relief angle, side cutting edge angle, clearance or end relief angle, axis, end cutting edge angle, side rack angle. So these are the major geometrical parameters of single point cutting tool. Yes. So yes, shank, flank, face, heel, nose radius, and cutting edge. So and what is shank? This is the main body of the tool. The shank is used to hold the tool. For example, tool holder. That is the main purpose of shank. And flank. The flank surface. The surface or surface below and adjacent to the cutting edge is called flank of the tool. And face. The surface on which the chips slide is called the face of the tool. Heel. It is the intersection of the flank and the base of the tool. It is a curved portion at the bottom of the tool, that is called heel. And nose. It is the point where the side cutting edge and end cutting edge intersect, that is called nose. And nose radius. The nose radius will provide long life and also good surface finish with it a sharp point on the nose, that is called nose radius. And cutting edges. It is the edge on the face of a tool which removes the material from a workpiece. The tool cutting edge consists of a side cutting edge, the major cutting edge, and end cutting edge, also called minor cutting edge, and the nose. So the important geometry cutting edge, which means where the tool and workpiece having the direct contact, thus that region called cutting edges. Yes, next. Single point cutting tool angle. Around we have a 6 different angles. The first one, side cutting edge angle, and second, end cutting edge angle, third, side relief angle, fourth, end relief angle, fifth, back rack angle, and the last one, side rack angle. So these are the major angle while playing the major role while machining. Yes, the first one, side cutting edge angle. This angle also is known as the lead angle. This is the angle between the side cutting edge and side of a tool shank. So, what is the side cutting edge angle? The angle between the side cutting edge and side of a tool shank. It is called side cutting edge angle, and it's also called as lead angle. And the second one, end cutting edge angle. This is the angle between the end cutting edge and the line normal to the tool shank. It is called end cutting edge angle. And third one, side relief angle. It is the angle between the portion of a side flank immediately below the side cutting edge and line perpendicular to the base of the tool and measured at right angle to the end flank. This is called as side relief angle. The angle between the portion of a side flank and it's immediately below the end cutting edge, which means the line perpendicular to the base of a tool. That is the common definition about side relief angle. And end relief angle. It is the angle between the portion of a flank immediately below the end cutting edge, the line perpendicular to the base of a tool, measured at the right angle at the end flank. And side relief angle, end relief angle, both are quite similar. So what is the major difference? A right angle to the end flank for end relief angle, the side relief angle, right angle to the side relief. That is the only difference between the side relief angle and end relief angle. And the fifth one, back rack angle. It is the angle between the tool face and line parallel to the base of the tool and measured in a plane perpendicular through the side cutting edge. The back rack angle is positive if the side cutting edge slopes downwards from the point towards the shank, and the back rack angle is negative if the slope cutting edge is reversed. So we have one different condition here, that back angle is negative. If the back rack angle is negative, the slope is side cutting edge is reversed. That is the important condition of back rack angle. And the side rack angle is a lost angle. It is the angle between the tool face and line parallel to the base of the tool and measured in a plane perpendicular to the base and side cutting edge. This angle gives the slope of the face of the tool from the cutting edge. The side rack angle is negative if the slope is toward the cutting edge, and the side rack angle is positive if the slope away from the cutting edge. So what is the condition for side rack angle? The side rack angle is positive if the slope is away from the cutting edge. So it's all about the side rack angle and signature. So signature of a single point cutting tool. So the shape of the tool is specified in a special sequence, and the special sequence is called tool signature. So what is tool signature? The shape of a tool specified in a special sequence, and this special sequence is called tool signature. The tool signature is given below. The first sequence, back rack angle, and next second sequence, side rack angle, and third sequence, clearance or end relief angle. The fourth sequence, side relief angle. The fifth sequence, end side cutting edge angle. And the sixth sequence, side cutting edge angle. And the seventh and the last sequence, nose radius. So these are the sequence, so 7 sequence for a single point cutting tool signature. Yes, a typical tool signature of a single point cutting tool is 0, 7, 6, 8, 15, 16.8. So that is the tool signature for each and every single point cutting tool having this particular tool signature. Yes, so what is 0, what is 7, what is 6, what is 8, what is 15, what is 16, and what is 0.8. Here the tool signature indicates that tool has 0. 0 is a degree of back rack angle, and 7 side rack angle. 6 indicates the end relief angle, and 8 indicates the side relief angle, and the 15 indicates the end cutting edge angle, and that 16 indicates the side cutting edge angle. The last one, 0.8, indicates the nose radius. So again I am repeating that 0 indicates the back rack angle, that 7 indicates the side rack angle, and 6 indicates the end relief angle, and 8 indicates the side relief angle, and that 15 indicates the end cutting edge angle, and 16 indicates the side cutting edge angle, and the last one, 0.8 mm, indicates the nose radius. So that is the tool signature for single point cutting tool. Yeah. So what are the advantages of a single point cutting tool? The main advantages are design and fabrication are easy comparing to the other cutting tool, especially multi-point cutting tool. This tool is little cheaper in price while comparing to the other cutting points. So these are the major advantages of a single point cutting tool. So, and what are the disadvantages of single point cutting tool? The main disadvantages are there are having little high tool wear rate. So single point cutting tool consisting the high wear rate. So obviously shorter tool life. Low metal removal rate when comparing to the other cutting tools, and low productive. So single point cutting tool is not suitable for the mass production, only applicable for low production and small scale industries. And what is the major application of a single point cutting tool? A single point cutting tool is used in several machines for producing a flat surface like lathe machine, shaper machine, and etc. So these are the major application of single point cutting tool. And thank you. So that's all about the single point cutting tool. I hope you all understood about the what is single point cutting tool, types of cutting tool, and the further classification of single point cutting tool, and geometrical parameters of single point cutting tool, and single point cutting tool signature. Okay, thank you.